All right.
All right, 3, 2, 1, and looks like we're good to go.
All right, great. Good afternoon, everybody. Thank you for joining. Um, so, hope y'all having a great weekend. And so we're going to give you a demo of the Shardus software. This past quarter, we've been working really hard to get all the bugs out of it, and try to handle all the edge cases. If you watched our last quarterly presentation, you know that we had an issue when the network was scaling down. We had some nodes getting out of sync, and we've been working really hard to find those edge cases and fix those. And also, we've been working on some performance improvements, and we've completely redone, um, reworked our whole gossip algorithm as well. So that's more optimized now. So I think we'll notice like some better performance on the network. So hopefully we'll get started. I'll turn it over to Amir. He can start sharing the screen, and then we'll start sending a load to the network. We've already got a network of 20 nodes started on AWS. So if you've watched our previous videos, you know how it works. Basically, we have 20 data centers across the world where we're starting nodes. And today we're going to scale it from 20 to like 80 nodes and then scale it back down. And so the main thing that we're trying to show here is first linear scaling. So you'll notice that as the network grows, it's going to be able to handle more transactions per second. And the other thing that we're demonstrating here is auto scaling, which means that the network is able to detect the amount of load being sent to it, and it's able to come to consensus on how many nodes it wants to have in the network, and allows more nodes to join the network. And then when it sees that it doesn't have as much of a load but has a lot of nodes in the network, it'll come to consensus and drop some nodes out of the network. So that's what we mean when we refer to auto scaling. So hopefully we'll be able to demonstrate that for you today. All right, Amr, go for it.
All right, everybody. Can you hear me?
Mm-hmm.
Okay. So I'm going to go ahead and share my screen. And what you're going to notice is the network that we have started on AWS should be up to about 20 active nodes right now. We're gonna go ahead and start spamming it and have it grow up to about 80 nodes. And then once it hits 80 nodes, we'll sustain for a little bit and then start shrinking it back down. And hopefully through this process, we don't want to see any nodes get out of sync or have any errors. And that's going to be our goal for today. So let's go ahead and start the spam. And then I'll turn it back to Omar, and he can talk a little bit more about Shardus and what we did this quarter.
Okay, Andrew, are you running the clients?
Yeah, I just got the spam started.
Okay. So yeah, so the way this works is that we have 4 separate clients that send a lot of traffic to the network, and that allows the network to see that, okay, it's getting a lot of traffic, it wants more nodes than what the current network size is, and then it starts allowing more nodes to join the network. Now, if you've never seen this setup before, So basically, each dot here on the screen represents a different server on AWS. We're using T3 mediums for the servers. So each of those servers has 2 CPUs and 4 GB of RAM. And they're distributed across 20 different data centers around the world. And these little red dots that you see flying around, those represent transactions. So the transactions are, coming from our clients that send a load to the network. Those clients are actually not shown. So it just kind of seems like, the transactions are just coming out of nowhere. But it's those clients that are sending the transactions. And once the transaction hits a particular node, that node will look at it, decide where it needs to get routed to, and then send it to the other nodes in the network appropriately. And that's where you see all these other transactions moving between the nodes. So the gray circles that you see are nodes that are waiting to join the network. So we've got a total of 80 nodes that can potentially join the network. And right now we have 24 nodes that have joined and become active. And there's 4 nodes that are syncing. So the ones that are syncing show up as yellow. So basically, when a new node joins the network, what it has to do is talk to some peers and catch up on the data that's already in the network. So, like, if any of you have ever run like a Bitcoin node or an Ethereum node, you know that that process can take, days and weeks. When Amr and I first tried to run a Bitcoin node, so this was back in 2011, even at that time, it took us like 2 days to get that node synced up to the rest of the network. Now, one of the things that we've done with Shardus is that nodes do not have to hold the whole transaction history. They're only holding the current state of the network. And even within that, the state of the network is sharded and divided among groups of nodes. So any one node would not be holding the complete state of the network. It'll just be holding, a fraction of that state, depending on how many shards there are in the network. So, so as you can see, as the network is being hit with a load, its desired number of nodes that it wants has actually gone up to 110. But we have the network parameters configured so that it doesn't allow more than 4 nodes to join the network at a time. So that's why it's going to take a little bit of while before it gets to a point where it's used up all of the 80 nodes that we've started up. And you can see that there's a average TPS value that's being shown here. So that shows the rate at which the transactions are coming in. And once in a while that might spike, especially when you're starting a client. And we have seen it like get hit with 474 transactions per second. And if a network gets to a point where, it can't handle that transaction load, the way we handle things in Shardus is that the nodes are allowed to just drop the transaction and tell the client that, hey, we couldn't process your transaction, just resubmit it again in a little bit. So this is kind of different than the way like the Bitcoin and Ethereum networks do it, where they accept every single transaction that comes in, but there's no guarantee of how long it'll take for that transaction to get processed. And so if the network load is heavy in the Bitcoin or Ethereum network, well, your transaction can go in, but, not get processed and, for hours. Sometimes I've seen some transactions not get processed for days, and it's really an issue. And, especially for the newcomers who are not aware of this kind of situation. And then sometimes people have to try to figure out how to cancel that transaction by sending a higher priority transaction with an even higher transaction gas fee and canceling that first one. So with Shardus, what we've decided to do is kind of have like a SLA in terms of, okay, well, we'll try to process your transaction within, like 5 seconds. And if we're not able to, then, we'll just start rejecting transactions. And in that bottom box there, you can see things like the queue time, the queue length, the external requests and internal requests that the nodes are seeing, and then a total network load that the network is seeing. So the queue time kind of gives you an idea about how long it's taking for a transaction that gets submitted to the network to actually go through the processing queue and then get processed and applied. The queue length kind of gives us an idea of how many transactions are sitting in the queue to be processed at any given time. Typically, those are the parameters that we look at to kind of decide how much load the network is seeing and whether the network wants to grow and add more nodes to the network. Let's see. And also there's that count up there of like the rejected transactions. So we've only had like 4 rejected transactions so far, and the network is continuing to grow. Also, you can see the total number of transactions that have been processed and applied. That's currently sitting at around 50,000. Now we're only going to be growing this network from 20 nodes up to 80 nodes and then scaling it back down to 20 nodes. And we're doing that just to kind of, for the sake of time, because the more nodes you scale it up to, the longer it's going to take. But last night we did run a test where we scaled it up to like 200 nodes, and we were actually getting close to pushing 2,000 transactions per second through the network. So we have seen it go to those numbers. One of the things that we're going to be doing next quarter is trying to see what are the limits of how large of a network we can push this up to. So that's one of our key goals for next quarter is really working on the scalability issue, because going up to hundreds of nodes is very different than when you're going up to thousands of nodes and tens of thousands of nodes. So that will kind of highlight other potential issues that may be in our software, and then we'll have to identify those and fix those kind of issues as they arise. but last night when we ran this network with 200 nodes in it, and pushed it up to 2,000 transactions per second, we actually processed like about 3.3 million transactions in like a matter of 1.5 hours or so. So yeah, let's see. So we're continuing to build up the network. We're up to 60 active nodes. We have 20 more nodes that we're gonna be having join the network. In the meantime, I'm gonna turn it over to Shazad Pai a little bit, and he can tell you a little bit about the kind of things that we've been doing this past quarter in terms of just the business development side and the clients that we've been talking to and so forth. So Shazad Pai, you want to give a quick update?
Thank you very much, Omar Saeed, and thank you very much to the team Shardus for the wonderful work each one of you all have been putting into the project so far. Just to give people an idea of what this means in terms of transactions per second, 2,000 transactions would be the upper limits of something like a MasterCard globally. So that's the level of speed we are seeing here. And I don't think there are very many projects out there who have actually shown this auto scaling in any of the networks. So this is something very unique, and we are looking forward to get this out to the general population and some of our potential clients who have been waiting very patiently to get us on board. In the last quarter, we have strengthened our relationship with most of our potential clients. In fact, we have one of them who's building a prototype with us, trying to use the features, getting themselves acclimatized to the developments within Shardus, and hopefully that should be the first to market. We're also building a lot of relationships from the marketing, and the philosophy at Shardus has been that we will not market the product until we have version 1 ready for release. So as soon as that happens, we plan to go to market and hope that will be a really good product to get into the market, a resounding success. So with that, let me hand it back to Umar Sayed and the team there. Thank you.
Okay, thank you so much. Yeah, I just wanted to mention something about that whole Visa transaction processing thing. So, you guys probably know, like, if you're familiar with the cryptocurrencies that are out there, currently, like Bitcoin, can process about 5 transactions per second. The Ethereum network does like 20 transactions per second. Now the Visa network on a regular basis is processing, I think, around 2,000 transactions per second, and they have a max capacity of around like 50,000 transactions per second. So a lot of times people want to compare and say like, oh well, has cryptocurrency networks caught up with the level of processing that Visa can do, and so that's kind of been a big push in the last several years to get blockchains that are much faster than what Bitcoin and Ethereum have been offering. So we're seeing a lot of projects coming out. If you're in the space, you probably are familiar, with projects like Polkadot and Algorand and Polygon or Matic, Binance Smart Chain, and there's a whole host of others. And these projects are they are increasing the total transaction throughput. Now, one thing that you have to keep in mind is that the way that they've been able to increase the transaction throughput is not the same way. Architecturally, the network is very different than the network for Bitcoin and Ethereum, right? So the Bitcoin network has, potentially tens of thousands of miners out there, although there's only like, less than a dozen miners that actually end up producing most of the blocks. Same with the Ethereum network. It has, I think over 10,000 miners out there. And again, same scenario. There's only, a handful of miners that actually produce the blocks or have the uh, the power and the capacity to be able to produce the blocks consistently. But the important thing is that those networks are a lot more decentralized, right? So like if some miners went away, there's still a whole bunch of other nodes out there that can jump in and start, producing blocks if those miners went away. Okay, so now these new networks, like the Binance Smart Chain, Polygon, Solana, Algorand, these kind of networks, the way they're achieving their high throughput is by reducing the number of nodes in the network. So some of these networks have only like about 10 nodes in the network. And I think the most I've seen is like probably about 100 or 120 nodes in the network. So when you reduce the number of nodes in the network, and also the way these nodes are able to join the network is based on a voting system or some sort of delegation where either the people that are holding the tokens can vote for the nodes or stake their tokens with the node to give that node the ability to become a block producer. This kind of leads to a little bit of centralization, where the network is not as decentralized as like what the Bitcoin or Ethereum network are, right? And I think over the probably the next 4 to 5 years, we may see some scenarios happen where it really tests these networks to see how decentralized they are, right? So we could have a scenario where like say a government in like Chinese government or something like that says, oh well, block this account because it belongs to somebody that we don't like. And the more centralized the network is, the easier it is for that government to reach out to the nodes that are running that network and tell those block producers to say, hey, don't process any transactions from this node. And so that is those kind of things I think will eventually happen, and we'll really get tested to see, are these networks really as decentralized as we think they are. So those kind of scenarios will then highlight, and people will kind of say like, oh, you know what, we really need to rethink and develop networks that are much more decentralized. So the approach that we've been taking with Shardus is that we want to have many, many, many nodes in the network, right? Like tens of thousands of nodes, and utilize all those nodes in an optimal way so that we can, get, lots of nodes that are doing sharding, get lots of transaction throughput because of that. So you have both, high scalability and a high degree of decentralization. So it looks like Andrew is hitting the network with more load now. So we've gotten up to the 80 nodes. And so it looks like, Andrew, you've got like 250 TPS going right now.
Let's see. I think I'm spamming, around between like 250 and 400. So
okay,
I can increase the spam now.
Yeah, do you want to maybe start cranking it up until we start to see some rejected transactions?
Yep.
And then we'll kind of know like what the limit is of this network. So the network's processed like 172,000 transactions so far. And then we've had 4 transactions that were rejected, probably because when we started a new client to hit the network with more load, it may have sent a lot of transactions at once. But as Andrew ups the TPS, we should start to see at some point the network rejecting more transactions. Also, we can try to keep an eye on like what the queue time is for a transaction. So that kind of gives you an idea of how long it's taking a transaction to get processed through the network. Also, the queue length will probably increase as we start hitting the network with more load. And you can also see that the total network load numbers are going up. Amr, do you have the chart showing somewhere
Yeah, let
where
me
we
see if I
can
can switch
show
over.
like the historical
There we go.
graph of, yeah, okay. So here on this chart, you can see like the average TPS, which is this the topmost line that's kind of bluish. And then the total load that the network is seeing is that red line. And you can see that as more and more nodes were joining the network, that load was going, less and less. And then whenever we increased the TPS, you can see that that load went up. And yeah, so and then the rejected transactions are shown with the yellow line, but they're really like very close to zero, so you don't really see too much there. So yeah, if you can switch back over. Yeah. So let's see. Okay, so we're at close to, I saw it get close to 500 TPS there.
I just launched another 200 TPS at it. And
Okay.
I wanted to mention that queue length, that goes up as the load increases, and that's like pretty natural, but it is one of our things that the network does consensus on to decide about scaling up and scaling down.
Yep.
But a nice thing is, even though we're loading the network pretty heavily right now, the queue time is not increasing much because the network's keeping up with it. Well, I'm finally spamming it hard enough now to get a few rejected transactions, but the vast majority of them are going through.
Right. Yeah, so we're getting like around, so we saw like 400 some transactions now totally get rejected. And that will probably start rejecting more as we keep up this load. But if you want to go ahead and stop the clients now, and then we can let the network kind of come back down, and maybe just keep like a small load going, like maybe 100 TPS or 50 TPS or something like that. So yeah, so this network with 80 nodes, we were able to get it to push to around 500 TPS before it started rejecting some transactions. So even if we say like we're getting like 400 TPS, it's basically like a 5x times the number of nodes in the network. Now that those numbers will vary depending on how many nodes are in a given shard. And one thing that I didn't talk about here earlier is that we currently have the network configured to have 5 nodes in a consensus group, and so that kind of gives us let's see, about 20 total shards. So we're getting parallel processing that's a factor of 20 above what we would get if the network was not sharded. And so, yeah, so changing your shard size will also impact how many TPS your network would be able to do. And of course, having more nodes in the shard, that also is a very important factor in terms of the security and the reliability and robustness of the network as well. So like for a public network, you probably actually want to have like at least 100 nodes in your shard. We're just doing this as a demo, so we're just using fairly small shard sizes, and so yeah, in those kind of networks, you would have thousands of nodes, and then have like maybe 100 or 200 nodes per shard for a public network. Okay, great. So we're seeing that the load is, well, coming down a bit, and the desired count now has come down below 200 nodes. So the network recognizes that it doesn't have as much load coming at it, and then wants to reduce the number of nodes in the network. And so, yeah, maybe you might need to leave it turned off for a little bit so that it goes through a few cycles and then reduces the desired count. Otherwise, this demo might take longer if that desired count doesn't come down below 80. So yeah.
Yeah, I just I think I had it the spam still on too high, but I restarted it at a lower rate now.
Okay, great.
But if looks like that should be okay.
Mm-hmm.
Yeah, another thing we can mention is like the new visual graphic we have for downsizing, those blue arrows and the yellow arrows.
Yeah, why don't you talk about that a little bit, Amr?
Yeah, so right now you can see it displaying the blue arrows. That kind of means that the nodes are consenting on that we should have fewer nodes, that the network should downsize. As we were spamming it, you saw like the yellow arrows it was showing. That meant that like the upward facing ones, that meant that the nodes are saying, oh, we need more nodes based on our load. They do this kind of gossip where they like kind of talk to each other to come to consensus on whether all of us should allow more nodes in, or all of us should, make the desired number of nodes less. And so seeing those visual indicators of that is really helpful when we do debugging and that kind of stuff.
Yep, great. Yeah, and so the desired count is now down to 150. And so, of course, these kind of numbers are configurable and so forth in terms of like how fast you want the network to adjust itself and so forth. We've kind of used some numbers that we thought would be good for this demo, but in reality, where I've worked with networks where we've had millions of daily active users, and during the daytime, the network is seeing such a load that maybe we need like 500 nodes to run the back end of this game or something like that. But then in the nighttime, the load goes way down, and then we may only need like 50 or 100 nodes. So typically in the real world, the loads change gradually usually over a 24-hour period. And so that kind of gives you a lot more time for your network to adjust to the load that it sees. So we're down to 120, and you can see that the overall net load is like really low. Andrew's just hitting it with a very low TPS right now. And pretty soon the network should start dropping some nodes out. And this was the part where last time in our demo, we ran into an issue, and then some of the nodes got out of sync. So what happens in a sharded network is that when there's a lot of nodes, each node has to hold less state data. But then as nodes are removed from the network, then each node is responsible for more and more state data. And so the nodes then have to communicate and synchronize and get the nodes from their peers, or get the state data from their peers. And that is where we had some issues last time. And hopefully, this time it'll go smoothly. So one other thing I wanted to mention is, some of the clients that we have looking at Shardus. So I've talked about these in our previous, quarterly presentations. So one of the key important ones is a project called Blood, and it's looking at, doing some work in the healthcare space, basically, providing more transparency and better, payment, processing and making that whole payment process a lot less frictionless for both the users and the service providers. So we've been talking to Blood, and they're actually using our current versions of Shardus to work with that and start, building their interfaces on top of that. Another project that we've talked to is one from South America. It's called Community. So that project is looking at creating a local marketplace, but one that can scale across like multiple cities and towns. And they eventually want to have that scale to many, towns and, even into multiple countries, but yet have it feel such that, each merchant that's in the network or the consumers that are using that network feel like they're, interacting with just the local, merchants and vendors. So it's almost kind of like a meetup kind of a thing, but think of it on the side of, the business and providing services to other people in your local area. Okay, and then another project is the African Payment Network, which is basically looking at helping to create a payment network across Africa, and they're actually in talks with the African Union, which is looking at potentially creating a cryptocurrency that could be used across all the different countries in Africa. So yeah, those are some of the projects that we've been talking to. Okay, so we're starting to see some of the nodes getting removed from the network. So the desired count now has come down to 20 nodes, and we have 74 active nodes in the network. So each cycle, you'll probably see a couple nodes get removed from the network. Now, we've limited the number of nodes that get removed to just 2 nodes. And the main reason for that is that since our shard size is small, you don't want to remove a whole lot of nodes at once. What happened?
Chat. There's some questions.
Okay, we'll get to that. So we don't want to remove too many nodes. at any given time, because you could get unlucky. And if you removed all, like say you had, you were removing 5 nodes at a time, and if you removed all 5 of those nodes from the one shard, you could get unlucky and have some issues with the nodes not having sufficient data for that shard. But of course, in a real world scenario, you would want hundreds of nodes to be holding the data for any given shard. So, removing like 5 or 10 nodes at a time wouldn't really be much of a problem. So, okay. I see that we have some questions. Kyle, do you want to maybe go through the questions and maybe
Sure.
ask what the questions are and then address them to
Sure.
one of
Can
the
you
team
hear me
members?
all right?
Yep.
Okay, cool. So looks like Casual Engineer Zombie has a question. Pure awesomeness. Have we had any news on Shardus stability?
Yeah. So part of the whole stability is kind of finding these edge cases with scaling, with linear scaling and auto scaling, and working to identify what those issues are, and then resolving those. I think we've made a lot of progress since last quarter in the stability of the network. So hopefully we'll see that the network is able to scale down here and not get out of sync. So yeah, I think we've done really good in terms of improving this stability of the network. And of course, we still, I feel we still have more work to be done in the future, because we're probably going to discover other things next quarter as we work on trying to see how far we can push this network.
Great. Another question, the open source wallet. Are there any updates about that?
Yeah, there seems to be a lot of interest in creating an open source wallet, and we are, definitely going to work towards that. We've kind of put that project a little bit on the back burner because we wanted to get, things knocked out this quarter in terms of the stability of our network and making sure that, we're able to scale up and scale down without any issues. And we did have to, come up with some very unique and different algorithms to solve those problems this quarter. And so we were really busy working on that. But we do want to go back to, creating the Coinica wallet, which is what we're calling it, which essentially will be an open source wallet that is modular, so that any developer can add their coin to it, and any DeFi project can add their capabilities of what that DeFi project does to this wallet. And essentially, the reason why we wanted to do this is because there's a lot of wallets out there right now, but not a lot of them are completely open source. So, I really feel that it's very important for people to have a wallet that's completely open source, where everybody can see what's happening on the front end, and how it's communicating to the back end and so forth. And so also, with Shardus, when Shardus is released and more projects start building with Shardus, they're going to create their own wallets, and those projects, you don't want like each project to create its own separate wallet, and then for the end users to have to download a different wallet for every project, right? So it would be really nice if there was like this one wallet that was modular, and then depending on what coins or tokens that you wanted that wallet to support, you could just, get them added in a modular way to your wallet. And so that, alleviates all this uh, additional work that every different team needs to do when they're building a wallet in terms of ensuring the security of that wallet. So that's why, we thought building something like Coinica is very important. And we do want to do that. But of course, Shardus is our main focus, and we want to get, the Shardus part working really well before we start working on these additional projects. So
Cool. We got another question if we are taking more. What's
yeah,
next
definitely.
what's next for the marketing? Maybe Shazad would like to answer that one, or
So the next steps, like Omar Said just mentioned, is the core focus has been to build a strong product, and that has been the primary focus of this particular group. As soon as we are close to a launch of the release one, we will start marketing heavily on various segments, various media, various platforms, etc. But that is still a few months away. It will probably be another quarter or so before we'll start seeing a lot of news about Shardus in the mainstream media. But in the interim, we are focused on building a grassroots support, starting from a lot of getting people together at various platforms, at various forums. We're doing a lot of conferences. Hopefully, with the surge of COVID eventually coming down, we'll do a lot more face-to-face conferences, and we're also building a strong ambassador program. So these are the immediate grassroots marketing efforts we're doing right now at this point in time. And the biggest splurge will obviously happen once the product is ready for market.
Yeah, and if I could add something to that, I feel like Shazad and Greg. Greg is actually on vacation right now in Florida. But yeah, so they've been wanting to push more with the marketing side, but I feel like I'm kind of holding them back and saying, hey, we don't want to be like a typical crypto project. I really view ourselves more like a company building infrastructure software, like say like a database company would be, right? And so, a lot of these projects, and people have gotten used to seeing a lot of these crypto projects just marketing themselves to basically, kind of raise the value of their token and so forth, right? So if there is no token, then, I don't think these projects would be marketing themselves, right? Like if you look at, say, something like MongoDB, where, you know, it's a software company building infrastructure software that gets used in a lot of e-commerce applications. They don't go around, kind of like marketing to the community so much. It's more, B2B type marketing. And so that's really, I think, with Shardus, that's really more the approach that I want to go, is that even when our product is ready, we want to go and talk about it at blockchain conferences. We want to, directly, talk to projects that could potentially use it, because there's a lot of projects right now that are running on, networks like Ethereum and other, smart contract platforms. But, they're really could use more TPS, right? And so being able to launch their own network would help them, kind of grow their capabilities of what their software can provide. So we want to talk to those kind of projects and show them Shardus and say, hey, you built your software on a smart contract platform because it was easy to get started. But now if it's easy for you to launch your own network, then maybe you might want to consider launching your own network. So that's a different approach to how we want to do marketing than a typical cryptocurrency project. So it looks like our network has come down to 20 nodes, or no, it's 28. So we still got a few more nodes that we can come down to. We've set the minimum number of nodes for the network to 20, so it'll never come down below 20 nodes. But yeah, we're getting there, and so far, we haven't had any issues. All the nodes are staying in sync, so that's really great. Kyle, anything else?
Yeah, there's a couple more questions. One is there an audit available? So are we doing any kind of audit once this whole thing, wraps up? And
Absolutely. So, the way we're planning to do it is first we're going to do internal audits of our own code. We've been so busy adding new features and, fixing things. We really need to do a thorough internal audit. Then the next step would be to hire a security company to do an audit of our code. And this will be a lot more effort than, like, say, auditing a smart contract, because you've probably seen like a lot of DeFi projects say that their smart contract has been audited. But typically those DeFi smart contracts are maybe, hundreds or maybe thousands of lines of code. But with Shardus, we have a lot more code. So it's going to be quite a bit of effort, getting that audited. And then the next thing we're going to do after that is we're going to make the code available to kind of like, white hat hackers that want to take a crack at, excuse me, that want to take a crack at trying to find, bugs and issues with the code and potential security flaws. And we're going to put out some kind of award for anybody that can to do that. So it's kind of a layered process in which we're going to do the audits and increase the security of the software.
Another question, if I don't know how much longer we want to do. Are we just going to answer all of them, or is there a time?
Well, I mean, we have this session going till like 2:00, and
Okay.
So people that only plan to stay till 2, they can leave. I think we can go a little bit longer than that, and try to answer all the questions.
So the next one was, do we have any idea about the tech stack for the open source wallet? So.
Yeah. So let's see. What were we building that in? Gerard, you probably remember better than I do. So it's mostly front end stuff. We weren't doing anything on the back end, but on the front end, do you remember what it was that we had started using?
We used React.
Okay, React.
Yes.
Okay, yeah.
Yes.
So we use React for the front end of that development, and ideally, what we create really would be kind of like one instance of the wallet, right? So it would be really good if more developers create a similar wallet like that with different technologies, and we just want to kind of break the ice and get the ball rolling with putting a completely open source wallet out there that's modular and show that, hey, whether you want Bitcoin or Ethereum or Dash or Monero or whatever, you can get all of these into one wallet, right? And you can just bring in just the parts that you really want into the wallet for the tokens or coins that you're interested in. And I think once we've kind of done that, I think a lot more people will want to go this route and create other wallets. So.
Sweet. Another one. What are the requirements if someone's going to create a DApp on top of Shardus?
Yeah, so that's an interesting question that we get a lot. So you have to keep in mind that Shardus itself is not a platform to create dApps on, right? Because dApps are usually created on like a smart contract platform like Ethereum or Binance Smart Chain and so forth. But Shardus is really the underlying infrastructure software. Now somebody can take Shardus and add a like an Ethereum virtual machine and a smart contracting language, and then launch a network, and then that network you could build dApps on top of. In fact, there is one other project that we've been working with. It's called the Lambden project, and they're also waiting for us to get Shardus developed. So Lambden has actually built their own smart contracting language and an engine to process that language and so forth. But they're not quite satisfied with the level of decentralization for their network. And so they're really excited about moving their virtual machine and their smart contracting language on top of Shardus, right? So eventually they would want to take the Shardus software and then add their layer to it and then deploy a network that would allow you to build your smart contracts using the language and features that Lambden provides.
Awesome. Can you outline the difference between Shardus and Avalanche Network? They seem like your competitor.
Yeah, so Avalanche, that's the project by, I'm forgetting the professor's name. He's out of Cornell University. Now, that project really is looking to allow more scalability for something that's fairly highly decentralized, right? Like the Bitcoin network. So Avalanche is one of those projects that wants to give more importance to decentralization and allow more node operators out there. But again, I think Avalanche is trying to not just be like the infrastructure software, but they're actually building a complete solution, right? So that's kind of like the key difference. And also Avalanche, if you get into the intricacies of how their blockchain works, it's still kind of like block based, and kind of groups a lot of transactions into blocks, but they use what's called like the Avalanche algorithm, but it actually is a buildup of what's referred to of like what is that called, the snowball consensus algorithm, and so they're really kind of doing like pre-consensus before the nodes send a block out there and say, hey, here's the block that we should all agree on. And so that kind of improves the rate at which you can generate blocks, and it helps reduce a lot of the energy overhead that is spent by networks like Bitcoin. So, but yeah, so Shardus is not block based. We process every transaction as soon as it hits the network, and then on the back end we group these transactions into what we call partitions, and then kind of push them off to the archive servers. But yeah, so that's one of the key differences between Avalanche and Shardus is how we process the transactions.
Cool. I think that's about it for the questions. I guess the only one I missed was Farin Ali. Is Shardus going to be presenting at IEEE virtual webinar at 10 a.m.?
We're working towards that. We would definitely like to present there, and we're trying to get on the list of one of the projects that can present there. So that would be awesome if we're selected to present there.
Cool. Well, thanks for all the questions, guys.
Yeah, and that's really good timing. We just a little bit past 2 o'clock, and looks like the network was able to scale up and scale down, and stay synchronized, which is the key goal that we're trying to shoot for. And you saw that when the network is had 80 nodes in it, it was able to process like 400 transactions per second. A network with 20 nodes would just not be able to get to those kind of levels. So that demonstrates linear scaling, and I think we were the first project to demonstrate linear scaling in a network that has state sharding, and now we've been basically, you just saw the demonstration of us showing auto scaling in a sharded network as well. So, all right, great. Thanks a lot, everyone, for attending the presentation. And if you have any other questions or anything like that, feel free to check into our Telegram group. And we also have like a Reddit group, and there's also a Discord channel that not a lot of people know about, but all of those are linked on the Shardus website. If you scroll down to our social media channels, and then also you can always send us an email and ask questions at info@shardus.com. So, all right, great. So with that, we'll wrap it up.
Thank you very much.
Thank you all for
Thanks,
being here.
everyone.
Thanks.